Alright, so welcome to Math 330 Differential Equations podcast for Chapter 1, Section 1. Integrals as general and particular solutions. So the definitions we're going to start out today is we're doing a first order differential equation, and what we want to do for this solution is choose the simplest form of our function of f of x and y, and the simplest form is to make function f independent of the dependent variable y. And if we do that, we can find a solution for a differential equation which ends up being an integral of f of x dx. So let's practice this. And this solution is called a general solution. This finding a general solution. So we have this differential equation, and what we want to do is solve it. So we have to integrate 3x plus 2 dx, and for us to do that, we apply the power law of integration, and then we get this solution. The idea is we don't know what c is, so I can choose different values of c, and I get these different families of solutions shown in the graph. And this is why it's called a general solution. Another example would be this differential equation. dy dx is equal to x e dx. And then we have to integrate, and then we want to solve this, so we need to integrate it. Well, to integrate it, you have to use integration by parts. So I need to select my u. In this case, it will be x, because I want to reduce the complexity of my function. And dv would be e dx dx. So du is equivalent to dx, and v would be equivalent to e dx. So our solution would be this. And now I just have to do an additional integral of e dx. But we know what that is. That's just e dx. So I get this general solution where I get a constant of integration. And if I select any value for that constant of integration, I get another family of solutions. So if you want what makes it a solution a particular solution, you have to give it an initial condition, or this value of, or declare what value you want the solution to be equal to for a certain value of x. And if we do that, say for our differential equation we did earlier, and we give it this initial condition, we can solve that differential equation. I need to figure out what c has to be to solve that differential equation. So I plug in my initial value for x, and I find out that my solution has to equal 3 at that point. To do that, c has to equal 3. And it's so my particular solution would be this, and that's only one solution of my family of solutions that we saw earlier. Well, I hope this helps. I apologize for posting it so late, but I've been dealing with software issues. I'll see you in class.